in Ethernet. So first question that we have arrived in our mind is that what are bridges? What are bridges? So if we go with the definition, we can say that bridges are a data link layer devices. These bridges are data link layer devices. Basically, you need to add here. It is a physical layer device. Bridges bridges are physical layer device plus data link layer device. Bridges works on physical layer plus data link layer and can connect to different networks as well as connect to different networks of different types. Means it can connect to different lanes like lane 1 and lane 2, as well as it can connect to different lanes with different types, like one is based on token ring, another is based on mesh topology, like that. So this is the basic definition that basically connects to different lanes. Now if we talk about, you can simply observe here this B1, it is a bridge here. It is connecting our lane 1 and lane 2. So this is one of my port and this is my another port. I will refer this 1 and 2 as a ports. Okay, so this B1 have no two ports, one port and second port. This first port is connected to lane 1 and this second port is connected to lane 2. Okay, so this A and B, I will term this as a stations. I will term this as a stations. So lane 1 have two stations A and B. Lane 2 have one station, that is C. And if I talk about B2, B2 is connecting with lane 2, B2 is connecting to lane 4 and B2 is connecting to lane 3. So I have three ports. B2 have three ports. One port which is connecting with lane 2, another port which is connecting to lane 4 and another port which is connecting to lane 3. So I have three ports with B2. So I have two bridges here. In lane 4 I have three stations, namely F, G and H. They are stations. Basically you can say they are host machines or PCs which are connected to lane 4. In lane 3 I have two more machines, that is D and E. So this is the typical architecture of the bridges, that how bridges are connected and how they connected with different lanes. So here lane 1, lane 2, lane 3 and lane 4 are there, and these lanes are connected using bridges. Important point here to note is that bridge works on physical layer as well as on data link layer. Now bridge used to connect two different lanes, important point, and bridge works on physical layer as well as data link layer. Okay, now you can note, guys, you can note it that suppose I have a bridge here, and this bridge here is connected to four stations on the left side. Suppose 1, 2, 3, 4. These are my four stations, suppose, and you can term it as a lane 1. On lane 1 I have four stations. On another lanes I have 5, 6, 7 and 8. They are further my stations. They are stations, and they are, you can term it as a lane 2. You can term it as a lane 2. So I have lane 1 and lane 2, and then and these bridges, this bridge is connecting lane 1 with lane 2, and in lane 1 station 1, 2, 3, 4 will have, and stations 5, 6, 7, 8 are on the lane 2. So if we talk about this bridges, on left hand side I have ports. This is called as port 1, which will connect stations 1, 2, 3, 4 with lane 1. And this is also port. Suppose it is port 2. Suppose it is port 2 which is connecting the host machines 5, 6, 7, 8 with lane 2. Okay, so this is the simple architecture of bridge. Now I told you that bridge works on physical layer as well as data link layer. So these entries will be mapped into the mapping table. So mapping table mapping table mapping table for bridge will hold this entry into the mapping table. How? That make address will be stored with respect to the port, because make address, which is a part of DLL, data link layer, right? So whatever the physical address of first machine is there, whatever the physical machine of first machine, the first machine, the physical address is termed as MAC address, media access control address. So whatever the physical address of first machine is there would be put under the mapping table entry of 1, and in front of it I will put the port number, that with which port of bridge it is connected. So host 1 is connected to port A, similarly host 2 is connected to port A, host 3 is connected to port A, host 4 is connected to port A. So this will be termed with the help of MAC address. I will put the MAC address of respective machines like 1, 2, 3, 4 here, and in front of that I will put the port number in which they are connected. Similarly, mapping table, this bridge will also hold the mapping table entries of MAC and port for 5, 6, 7 and 8. So I have port B with them. So my host 5, 6, 7 and 8, they are connected with port B. It is the part of LAN 2. So this is the mapping table entry for bridge, guys. This is the mapping table entries for bridge. A network bridge is a device that divides network into segments. You can term it as a segment 1. You can term it as a segment 1. You can term it as a segment 2. You can term it as a segment 2. No problem. So a network bridge is a device that divides the network into segments. The next point is each segment represents a separate collision domain. So the number of collisions on the network is reduced. So whatever these stations 1, 2, 3, 4 will make a separate collision in bridge, and 5, 6, 7, 8 will make a separate collision. So the collision domain area is this. This is the collision domain area for segment 1. This is the collision domain area for segment 2. Next one is each collision domain has its own separate bandwidth. So a bridge also improves the network performance. So each collision domain will have a separate bandwidth. It may depend on the lane and type of lanes to which bridges are connected. So these are some of the important theoretical points which I have discussed with you in respect of the bridging concept. Basically it is very short topic, newly added topic in GATE 2021 onwards, and these are the important points, because if they want to ask question from bridge, there are majorly theoretical question consisted in that, or they may ask some kind of conceptual questions. So I am discussing these points with you. Now if I talk about types of bridges, then there are two types of bridges, basically static bridge and dynamic bridge. What does static bridge means? Static bridge means mapping table entries would be manually performed. What are mapping entries? I have told you now that the mapping entries are consisted that make address of the respective bridge, and with respect to make address I will add port address. So suppose make address of first machine is connected to port A, make address of second machine is connected to port A, make address of third machine is connected to port A, make address of fourth is connected to port A. Make address is the physical address of machines. So machines A, B, that is machines 1, 2, 3, 4 are connected to port A. You can take it from this diagram. Machines 1, 2, 3, 4 are connected to port A. This is port A. Suppose this is my port A and this is my port B. Okay, this is port A and this is port B. So this is in this manner we need to manually add these entries in static bridge. But if we talk about dynamic bridge is also called as learning bridge, or it is also called as transparent bridge. It is the synonyms of dynamic bridge. You may face that what is learning bridge, transparent bridge or dynamic bridge. They all are same, equal, synonyms of each other. So in dynamic bridge, the entries in the mapping table will automatically learn the entries and fill it. So suppose it is a bridge which is connected to PCA, PC1, PC2, PC3, PC4, and this bridge is connected to another lane, suppose PC5, PC6, like that. So this bridge will automatically learn by, suppose one is sending data to 5. So when one will send data from to 5, it will automatically learn one by one when the machine get used in this network. So in dynamic bridge, they will automatically learn the entries and fill it. So in dynamic bridge, the bridge will automatically fill the entries in the mapping table based on the communication that will happen. So suppose third is sending entries to 4. So third and 4 will be in the front side of bridge and it will fill the entries in itself. So automatically it will get filled. So static bridge you can use in small networks, but there is a need of dynamic bridge if we are connecting to so many lanes and there are so many devices in that lanes. Okay, so these are the types of bridge. They are the types of bridge. Now we are talking about the capability of bridges, guys. It is very important topic, and GATE may ask conceptual questions in bridge from this topic. Your GATE exam may ask capabilities of bridges directly as a theoretical questions, because if you will see 40% of questions you will get as a theoretical or conceptual question in a easiest level. So you may get such kind of questions from this topic. So what are the capability of bridges, guys? The very first capability is filtering. Filtering is the first capability of bridge. What is filtering? We will discuss it in the next slide. Slide by slide we will discuss that what is filtering, what is forwarding, what is flooding, and what is store and forward. But as of now you can note it that capabilities of bridges are filtering, forwarding, flooding, and store and forward. They are the most majorly used capabilities of bridge. Now if I talk about filtering, then if any bridge finds the source MAC address and destination MAC address are on the same lane or are on the same lane, then it will not forward it and simply it will filter it. So what it is indicating? See here, guys. Suppose it is my bridge. And from that bridge, station A is get connected, station B is connected, station C is connected, station D is connected. In that bridge, station P is connected, station Q is connected, station R is connected, station S is connected. Okay, so filtering, it is a capability of bridge. What it means? See here. Suppose R wants to send message to S. In this case, what bridge will use as its capability? How bridge will work? So bridge will simply see that R and S are on the same side of lane. That is, it is a part of same lane. Suppose it is lane 2, it is lane 1. So bridge will observe that R and S are on the same side of lane. So there isn't any need of R and S message in bridge. There isn't any need of forwarding it to the entry of bridge. So it will filter message. On the place of forwarding, it will not forward the message, it will filter the message and R will directly send the message to S. It is called as filtering. Suppose P wants to send data to Q, then data will not get stored in bridge, it will not forward to bridge, because bridge has a capability of filtering. That is why P will directly send data to Q without having entries in the bridges, without forwarding the data to bridge, due to the property of filtering. This property is called as filtering. That if machines are on the same side, then suppose B wants to send data to D, so source address and destination address are on the same side of lane na. That is why there isn't need of forwarding, they will simply filter it. Are you getting the concept of filtering in bridge, guys? Are you getting this capability of filtering in bridge? Please comment me in the chat box who have attempting who are attending this session, please comment me. Are you getting what I am telling to you, that what is the filtering capability of bridge? Okay, Manjit, good. Okay. The next capability is forwarding. The next capability is forwarding. So in forwarding, if any bridge finds that source MAC address and destination MAC addresses are on different sides of lanes, then it will use forwarding. For example, it is my bridge, and in this side I have station P, Q, R, S. Suppose it is my lane 1 and it is my lane 2. Lane 2 have devices like A, B, C, D. Okay. Now suppose A wants to send message to P. In this case, A wants to send message to P. So what will gonna happen there? There is a need of forwarding now, because bridge will find that source MAC address. Here it is a source MAC address. Source MAC address is the MAC address of the destination or the host PC which wants to send message. It is called as source MAC address. So source MAC address is on the left hand side, that is on the part of lane 2. And destination MAC address is on the different lane, that is on the right hand side of the lane or of the bridge, or we can simply say that on a different lane. So if such condition arrives that source MAC address is on the different lane and destination MAC address is on the different lane, then in that case the bridge will use forwarding. So this is the second capability of bridge. So first one is filtering, that source MAC address and destination MAC address are on the same side, then filtering will use. But if source MAC address and destination MAC address are on different sides, then forwarding will use. So these are the first two capabilities of bridges. Okay guys. Now the next one. Next one is flooding. Next one capability is flooding. What is flooding capability of bridge? If a new station is added, suppose my bridge is this, suppose it is my bridge, and with this bridge, suppose I have two stations here, A station and B station, and here I have two stations, P station and Q station. Okay guys, in lane 1 I have two stations, and in lane 2 I have two stations. So if new station is added, so for example, a new lane with the name X is added here. It is new new station is added here. Okay. So if new station is added, then currently bridge don't have any information about this station. In this case, bridge will use flooding. I told you na in static routing algorithm that what flooding is. Flooding is bridge will send packets along this port. Suppose this is port A and this is port B. So bridge will send data packet to this port as well and this port as well. So in this link, if our new station is added, it will get the packet. If this station is having that new station, this station will get the packet. So this is the capability of flooding bridge. Flooding is the capability of bridge, that if newly station is added on any side of lane or in any lane, then by using flooding we can send the packet to the newly arrived station, right? So flooding will done in order to send the packet to the newly arrived station. Is it clear guys that what is filtering, what is forwarding, and what is flooding in terms of capabilities of bridges? Is it clear to everyone guys? Please comment me in the chat box. Is it clear to everyone? Flooding, forwarding, and filtering. Okay, very good. Next one is the next capability of bridge. The next capability of bridge is store and forwarding. So in store and forwarding, what happened? No collision occurs inside a bridge. Bridge will store the packet, and whenever it will be convenient for a bridge, then it will go to forward it. For example, what it means, see here. Suppose it is my bridge again, and here it is my station 2, it is my station 3. here I have station 1. Okay, now suppose I have one more station like 4 here. It is my lane 1 and it is my lane 2. To this lanes bridge is getting connected. Bridge is connecting to these two different lines. Now, 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 suppose this 4 has sended data to 2. This host 4 has sended data to 2. At the same time, at the same time, at the same time, this 3 has sended data to host 1. At the same time, host 3 has sended the data to 1. So what happened? Bridge will inside bridge no collision will be occur. So bridge will store the packet either from 4 to 2 or either from 3 to 1. Whatever packet will come first will forward it and will see that whenever it will be convenient for bridge it will send that packet next time. Means suppose 4 to 2 packet is arrived first, but at the same time 3 to 1 is also arrived. So it will store the packet of 3 to 1, first forward the packet to second, and then forward the packet of 3 to 1. So it is store and forward capability of bridge. By this, bridge is capable of avoiding collision. By this, collision will be avoided. Separate collision area will be there. That is why bridge is called as collision separation device between these lanes. Okay, Manjit, I am explaining it again. I am explaining it again quickly. Suppose there are two lanes, lane 1 and lane 2 are there, and in lane 1 and lane 2, suppose in lane 1, one host and 4 hosts are connected, and in lane 2, second host and third host are connected. So suppose it once suppose our this PC fourth PCs want to send information to second PC. At the same time this third PCs also want to send the information to one time. Means at the same time 4 wants to send message to second, and at the same time 3s want to send the packet to 1. So what will gonna happen in that case? In that case, bridge will store the packet of the last arrived packet and it will forward the packet of the first arrived packet. Suppose fourth, suppose it is the source address, source MAC address, and it is destination address for first packet, and suppose second packet is for source address, third is there, and destination address for second packet is this one. So it will send packet from fourth device to second device firstly. At this time it will store the packet of this one. Once this packet is forwarded completely to device 2, bridge will get free. In this time the stored packet from device 3 will be forwarded to this one. So this is the store and forwarding technique. Is it clear, guys? Okay, okay, very good. So these are the four capabilities. We have discussed filtering, we have discussed forwarding, flooding, and store and forward. These are the four important capabilities of bridge, and gate may ask any theoretical or conceptual question from this because it is newly added topic, right? So we need to consider this. So these are the capabilities of bridges, guys. Very, very important topics. Now next one is spanning tree algorithm. Spanning tree algorithm for bridging concepts in Ethernet. The next one is spanning tree algorithm for bridging concept. So spanning tree algorithm, it is same as of the data, as of the algorithm and data structure. Whatever we have discussed in data structure and algorithm, it is the same algorithm. How to work on spanning tree algorithm now? Here you need to focus on points. Point by point we will go. Point by point we will go. But before discussing spanning tree algorithm, spanning tree algorithm, let us focus on this architecture of spanning tree algorithm. By this architecture, you will get to understand spanning tree algorithm for bridging very, very easily. So suppose I am making that one for you. Suppose this is lane 1, this is my lane 1. Because guys, focus this is the last topic of bridging. This is the last topic of bridging. What? Spanning tree algorithm. And if you will got understand, you will get 100% marks if they will ask from these four topics of today, right? So this is lane 1. Suppose this is lane 4. Just focus here one by one. and slowly I will explain to you so that you can't get stuck anywhere. Suppose this is lane 1, this is lane 4, and lane 1 is connected with a bridge named as bridge 1. Bridge 1 is the first port here, and it is second port here. Second port is further connected to lane 2. Suppose it is lane 2, and lane 2 is further connected to lane 4 via bridge 4. Via bridge 4 it is connecting to lane 4. Suppose it is port number 1, it is port number 2. Now lane 2 is connecting to lane 3. Suppose here it is a lane 3, and lane 1 is connected to lane 3. Lane 1 is connected to lane 3 using bridge 2. It is first port, number 1 port, and it is second port. And lane 3 is connected to lane 4. Lane 3 is connected to lane 4 using bridge 5. Using bridge 5 it is connected to lane 4. Suppose it is port number 1 and it is port number 2. And using bridge 3, lane 2, is connected to lane 3, as well as lane 2 is connected to lane 4 using bridging 3. But bridge 3 have 3 ports, 1 2 3. So suppose this is my first port, this is the second port, and this is the third port. Okay. So B1, here you can note B1, B2, B3, B4 and B5. They are bridges. They are the bridges. And 1, 2, they are the port numbers. They are the port numbers for each bridge. For each bridge, they are the port numbers. And lane 1, lane 2, lane 3 and lane 4. These are the lanes which are connected like this. So by example we are learning this. By example we are going to learn this. Okay, so this is our example of spanning tree algorithm in bridging concept so that you can understand it better. Okay, now coming up to spanning tree algorithm, what we will take one step at a time and we will solve it. So step 1, you can note it if you are if you can note it simultaneously, guys. You can note it simultaneously. Okay, so step 1 is every bridge has a built-in ID. You can note it simultaneously. Every bridge has a built-in ID. Okay, every bridge has a built-in ID. The one with the smallest ID is taken as a root bridge. The one with smallest ID, the one with the smallest ID will be taken as a root bridge. It will be taken as a root bridge. One with the smallest ID, it will be taken as a root bridge. So here if you will observe in the example, B1, it is the ID of bridge 1, bridge 2, bridge 3. So 1, 2, 3, 4, 5 are the IDs of bridge 1. So the lowest ID is B1. So we will assign B1 as a root bridge. It is step 1, guys. It is step 1 that whatever bridge have a lower ID, we will assign that bridge as a root bridge. Okay. It is step 1. Got it, guys? Got it? What is step 1? Whatever bridge have a lowest ID, we will assign that bridge as a root bridge. So this is B1. It is a root bridge. Good. Now step 2. Step 2 is mark one port of each bridge with closest to the ridge bridge as a root port. We need to mark one port of each bridge. We need to mark one port of each bridge as a root port. which is closest to root bridge, which is closest to root bridge. So if you will observe here, I am changing the color of pen. If you will focus here, if you will focus here, b1 is a root bridge, it is a root bridge. So b4, there are two ports, port 1 and port 2. Focus here guys, port 1 and port 2. So guys, 1 is closer to root bridge, this 2 is taking one hop, that is it will go to b3 and then it will get connected to b1. But port 1 can directly connect to b1 by one hop. So this one bridge is connect, I will say this port as a root port. So I am marking this star. This star is denotifying the port is root port. Is it clear guys? Is it clear that why port 1 of b4 is root port? Is it clear? Please comment me in the chat box. Is it clear that why port number 1 of b4 is root port? Good. Now if I talk about b3, you can answer me Manjit. Out of port 1, port 2 and port 3, which port should I consider as a root port? Answer me. No Manjit, it is root port because b4 is closest to b1. This port is closest to b1. That is why I considered it as a root port. Now if I talk about b3, b3 is connected directly. B3 is connected directly to the root bridge with the one port. So I will consider this port as a root port. Because if I will consider 2, then I need to go to b2 and then I can go to b1. And if I consider b3 via b5, then via b5 I need to go to b4 and the b1. But the closest port, which is closest to root bridge, is termed as root port. Is it clear, Manjit? Whatever port is closest to bridge, is termed as root port. So this port 1 is closest to b1. This port 1 is closest to b1. That is why it is considered as a root bridge. This star is marking. I am marking this star. It is considered them as a root port. Is it clear? Okay, Manjit. Okay, Manjit. I got it. Got it, Manjit. Good. Now, yeah, if I talk about b5, guys, b5. If I talk about b5, then answer me, Manjit. In b5, out of 1 and 2, which one is a root port? Because if I go to the root bridge from b5, I can face b3 and b1. And if I go with port 2, I will face b4 and then I will go to b1. Means either I go from port 1, it will take 2 hop, that is this is the one hop, this is the another hop. If I will go to port 2, this is one hop and this is another hop. So either side of port, that is 1 or 2, from both the side I am facing my root bridge as a closest, because from port 1 I am taking 2 hop, one hop, that is 2 hop, and from b5 I am taking this one as a 1 hop and this is a 1 hop. So from both side I am getting the same root, same hop, same number of hops. So I can consider any port as a root port. Suppose I consider this port 2 as a root port. Suppose I consider this port 2 as a root port, because from any side I am getting same number of hops. So I am considering the port 2 of b5 as a root port. Okay. Now consider b2. B2, the first port of B2 would be considered as a root port. Why? Because it is closest to the root port. Because if I consider port 2, then from port 2 I need to go B3, then from B3 I need to go to B1. But B1 is directly connected to B1 via port 1. So it is closest. So port 1 is considered as a root port. So how I assigned a root port to each bridge is clear, guys? Please comment how I assigned a root port. How I assigned a root port to each bridge. Is it clear to everybody? Is it clear to everybody, guys? Good. Good. Very good, guys. Very good. Now, step 3. We have done step 1. We have done step 2. Now time to see step 3. What is step 3 in spanning algorithm of a tree? Every lane chooses a bridge. Write it. Every lane has chooses a bridge. Every lane has chooses a bridge closest to it. Every lane has chooses a bridge closest to it as a designated bridge. As a designated bridge. As a designated bridge for that lane. For that lane. For that lane. Now make that correspondent port as a designated port. Make that correspondent port as a make that correspondent port as a designated port. So see here guys, each lane, suppose lane 1 is here, so each lane chooses a bridge closest to it as a designated bridge. So if you will see here, this lane, what is closest to it? B1. Question: every lane has chooses a bridge closest to is a designated bridge, and for that lane make that correspondent port as a designated port. So for lane 1 if we talk, I will assign designated port with the hash symbol. With hash symbol I will assign designated port. Okay, I will assign the designated port with the hash symbol. So for lane 1, the closest bridge is B1 and it is also root bridge. So I will consider the port 1 of root bridge as a designated port. For lane 1, it is done. Come to the lane 2. For lane 2, for lane 2, I will I will consider the port 2. I will consider the port 2 of the bridge as a designated port for lane 2. So I have done with the lane 1, lane 2 because it is closest to it, and I will give priority to the root bridge. So bridge 1's first port is designated port for lane 1 and bridge 1's second port is designated port for lane 2. It is clear? Now if I talk about lane 3, then what is closest bridge for lane 3? The closest bridge is B2. Why? Because from B2 to B1 I can traverse directly. But if I will choose B5, then for B5 I need to go to B4 first and then I will go to B1. So it is somewhat lengthier. It is not closest. If I talk B3, then I need to go to B3 first and then I need to go to B1. But B2 and B3 is same. So suppose I am choosing B2 second port as a designated port. B2 second port as a designated port lane 3. Okay. So B2 second port is chooses as a designated port for lane 3. And it is now time to discuss the designated port for lane 4. So for designated port of lane 4, if you will see if you will see if you will see the port number 3, it would be the closest one. Why? Because from B3 directly I can reach B1, from B4 I can also directly reach B1, and from B5 is somewhat not closer. So either I can choose third port of B3 as a designated port for lane 4, or I can choose second port of B4 as a designated port for lane 4. I can choose anyone. So suppose I am choosing the third port. I am choosing suppose the third port of lane 4 as a designated port. So I have chooses root port for each bridge and I have chooses designated port for each lane. Is it clear guys? Is it clear? Tell me, is it clear to everybody or not? So that I can move, I can proceed further. So that I can proceed further. Please answer me guys. Is it clear now? That how to assign root port and how to assign designated port? It is the step third we have done. Clear? Very good, Manjit. Now the last step is step 4. In step 4, what we need to do, mark the root port, mark the root port and designated port. Root port means all the star marked, and designated port matlab all the hash marked. So mark the root port and designated port as a forwarding port. We need to mark it as a forwarding port. We need to mark it as a forwarding ports and block the remaining ports, and we need to block all the remaining ports. So see here, I am changing the color, I am making it highlighter so that you can understand it clear, guys. You can understand it clear with the help of marker. See here, I will remove this part. Why? Because I don't have root port here and I don't have entry of designated port here. I don't have entry of root port here as well as I don't have designated port here. Means I don't have star as well as as well as hash here. So I will remove this port, this part. I will block this port, that is second port of this. I will also block first port of B5. Why? Because I don't have any star and hash entry here. Okay, Shivang, I will do it. Once I will complete it, I will do it. Don't worry. I will also block the second port of B4 because I don't have entry of star here and hash here. So I will also block the entry of it here. Okay. So I have blocked this port, I have blocked this port, and I have blocked this port. And all other port will remain same. And all other ports will remain same. So guys, whoever asking for the step 3, just focus here. I am explaining step 3 once again fastly because Shivang has asked it. So Shivang, focus here. Step 3 is that every lane has chooses a bridge closest to it. Lane 1, what bridge it is closest? According to the root bridge, B1 is closest. So the first port of root bridge, that is first port of B1, will be marked as a designated port. Why? Because it is closest to lane 1 and B1 is a root bridge, so we have to give priority to it. That is why I have marked the port 1 of B1 as a designated port. So I have done the entry of lane 1. For lane 1, designated port is B1's 1. For lane 2, there is a two bridges which is connecting B4 and B1. But I need to go to root bridge. Ultimately I need to go to bridge 1. That is why the second port of B1, the second port of B1 is designated port for lane 2. So first port of B1 is designated port for lane 1 and second port of B1 is designated port for lane 2. Is it clear? Is it clear now? Is it clear, Shivang? B1's first port is designated port for lane 1 and B1's second port is designated port for lane 2. Now focus on lane 3. Lane 3 is connected to B2, B5 and B3. But which bridge is closest? B2 is closest and B3 is closest. We can choose any bridge. We can choose any bridge. It is upon us. So I chooses port 2 of B2 as a designated port for lane 3 because it is the closest one according to me. I can also choose the port 2 of it, no worry. I can choose anyone, no worry. But according to your aptitude, you can choose it. It will not impact anyone. It will not get a impact anything on the solution, right? Now for lane 3 we have chooses second port of B2 as a designated port. Now for lane 4 I have chooses B3 third port as a designated port. However, I can also choose the second port of B4 as a designated port, but I chooses third port of B3 as a designated port for lane 4. Right. So these are the designated port entries for this one. What you are asking, Manjit sir, we have to see from root bridges which port is closest. Yes, Manjit, correct. So if I will choose second port of bridge 4 as a designated port for lane 4, then I will block this line. but as I chooses designated for this, so I didn't block this. Is it clear, guys? Clear? The third step is clear now to everyone. The third step is clear to everyone. Very good. Now focus here. Now focus here. How my bridge will look like now, because I have removed this. I have removed this port, I have blocked this port, and I have also blocked this port. So my bridge structure would look like that. This is lane 1, it is bridge 1, it, it is lane 2, it is B4, it is star mark. I will not add this entry now because this is blocked. This is my lane 4, this is my lane 3. Lane 3 is not connected to 2 now, only 1 is connected to B2. Okay, and lane 3 is not connected to B3 as well. It is connected, lane 4 is connected to B3 now. And I also have my star marking, means I need to connect B4 with B3. I need to connect B4 to B3 with port 1. It is port 3, right? It is port 1 and I have star mark here. Okay guys, so if you will see, this was my bridge architecture, which is creating the cycling problem, which is creating the cycling problem that that packets will revolving around each bridge. So I have converted that cycle into tree. Now you can see here this cycle is converted into tree here. Suppose I want to send data from B1 to B2, it will be directly sent like that. Suppose B3 want to send data to B2, B3 will go through this path and send data to B2. Okay, so we have one more B5 na. So B5 is connected here guys, B5 is connected here with second port. So I have connected B1, B4, B3, B2, B5, B1, B4, B3, B2, B5. Okay, and B4. So if B5 want to send data to B1, B4 can send data via B3, and B3 will send data to B1, and via B2 we can reach. So if you will see, this bridge will creating the cycling problem, which is resolved by using spanning tree problem. By using spanning tree algorithm, we have resolved this problem, and you can observe it is nothing but a spanning tree, which we have already discussed in the data structure and algorithms, that how to construct a spanning tree. For one graph there may be more than one spanning tree. For one graph there may be more than one spanning tree. Yes, B2 to lane 3 it can connect guys, no problem. Yes Manjit, B2 to we can connect lane 3, it is still a tree, it is not making a cycle. Okay, no problem, no worry. Is it clear guys that how to solve spanning tree algorithm for bridging? Is it clear to everyone? Shivang, switch doesn't have any collision separate area. Actually, in bridge, I have discussed that in bridge we have separate collision area, but but our switch doesn't have separate collision area. If two packets are simultaneously sended by different switches, then it will get collide. But bridge have a separate collision area, because we have discussed in the capabilities of bridge that it has store and forward capability. We have discussed here that capability of bridge is filtering, forwarding, flooding, and store and forwarding. So it will avoid the collision, but switch can't avoid the collision. It is the basic difference between them. Okay Shivang? Manjit, cycle is here. Cycle is here. In our problem, we have cycling problem like that. But in tree, we don't have cycling, which is resolved by using spanning tree problem. So Manjit, clear? Shivang, your problem I also solved. Is it clear? Shivang, okay. Manjit, your problem is also solved. Clear? Okay, okay. So this is the bridging concepts in Ethernet. So, okay, students, Ashik is asking for earlier slide. So, Ashik, let us recap it. I started the bridging concepts of Ethernet from the basic introduction of bridges. It is the first slide. First, directly you can take a screenshot because we have a shortness of time here. And after that we have discussed important points of Ethernet mapping table of Ethernet, and that how mapping table will be done under bridges. After that we have discussed some more important points. This is the third slide of bridging. After that we have discussed the types of bridges, that is the basic differences between static bridges and dynamic bridges. After that we have discussed the capability of bridges, which is considered as a very important point. Four capabilities are, we have discussed filtering, forwarding, flooding and store and forward in very detail. You can watch the lecture, very detailed we have discussed this. And after that we have discussed the spanning tree algorithm. There are four steps. In first step we assign the root port for each bridge. In second step we assign the designated port, and after that we eliminate the remaining states which is not having any designated port or root port, and by that this cycling problem of bridging is solved. And spanning tree is will convert our bridging this cycle bridges as a tree bridge. And so our cycling problem is resolved. And this is the bridging concepts in Ethernet. So by that they can ask that this is the concept, right? So I think it is clear to everybody that what are the concepts under bridging concepts of Ethernet. What are the concepts under bridging concepts of Ethernet? I hope it is clear to everybody now. Clear, guys? Totally clear. Very good. As a practice question, I am giving you one more question, and after this, we will end our session, right? As a practice question, I am sharing a question with you. Suppose a bridge is here, bridge A is here, its bridge ID is 2000, and bridge B is here, bridge B is here, and its bridge ID is 3050, and we have bridge C here, whose bridge ID is 5010, and we have bridge D, whose bridge ID is 4000. They are connected like that, and we are facing cyclic problem in it. And my bridge A is root bridge. My bridge A is root bridge. So guys, tell me what would be the spanning tree architecture of this bridge? How will you solve the cyclic problem of this bridging problem? Just answer me that what would be my spanning tree look like? Answer me. Just apply all the just apply all the concepts which I have discussed with you, and then I can continue and I will conclude the session, guys. Just answer me. Just try in your notebook. Just try in your notebook, guys. Just try in your notebook. I have shared you a link. You can watch the opportunities for GATE CS candidates outside the GATE exam as well as non outside of the GATE exam, right? So you will get help with that. You can watch that lecture, guys. And I am sharing one important link again, that what you need to do and don'ts. What you need to do's and don'ts for the GATE exam. Do's and don'ts for GATE exam, right? That how will you perform do's and don'ts. For do's and don'ts, you can watch this. For do's and don'ts, you can watch that. Okay, these are the two important links which I have sent it to you. You can watch that, do's and don'ts. So guys, have you solved it? Have you solved it, guys? Okay, let me tell you now. It is my root bridge, guys. It is my root bridge. It is my root bridge. So in this root bridge, if I consider B and port C, okay, then you will observe that I need to construct root port. So suppose these are the port 1, this is the port 2. You can consider any port. These are the 2 ports for this bridge, these are the 3 ports for this bridge, 3 ports for this bridge, and 2 ports for bridge D. So if you will see, whatever the root port will be on the side which have laser, which is connected to the closest, which is closest to the laser root ID. So it is the root port for bridge. It is the root port, that is I am marking with a star, because it is connected to the laser ID of root, laser ID of the bridge. The laser ID of bridge is 2000, whereas it is connected, its ID, it's this bridge ID is somewhat higher, this bridge ID is somewhat again higher. That is why I have make this port as a root port for A. If I consider for C, if I consider for C, again my root port would be this will, I will consider this port, this side port, upper side port as a root port, because it is connected to the lowest, it is connected to the lower number of root port, it is connected to the lower number of root port, because 2000, this 2000 is a we can, you can consider it as a lower ID, it is the lowest ID of the any bridge. So whatever the lowest ID of any bridge, we will make root port to that. Now this is the root port for this one and this one. If I consider root port for bridge D, for bridge D, the root port will be this. The root port would be this one, that is on the left side. Why? Because the ID, that is 3050, it is the laser ID, the bridge ID of root B, the bridge ID of bridge B, bridge ID of bridge B is lower than bridge ID of C, because bridge ID is 50110, which is higher. That is why I will make this port as a root port. Okay guys, now if you will see that I need to assign designated port. Designated port will be assigned for each lane. For each lane I need to assign designated port. But you can consider it as a same lane. It is a part of same lane. It is a part of same lane. So if you will consider here, I will remove this link and I will remove this link. So my bridge architecture would be look like that, because it is a part of same lane. That is why no need to assign designated port. Designated port is assigned for each lane. But you can say that here single lane is there. That is why I can say A is connected to C like that, and B is further connected to D, right? So this is the spanning tree for this one. This is the spanning tree for this one. Is it clear to everyone, guys? Answer me, is it clear to everyone or not? Answer me that how I make the spanning tree ABCD like this for from this problem. Is it clear to everybody or not? If any candidate is stuck in this problem, answer me. I will solve it again. No worry. I will solve it again. No worry. But don't, any candidate don't have any kind of confusion in that. Bridging concepts in Ethernet. Is it clear to everyone? Is it clear to everyone, guys? Okay, clear to you. Okay, very good, guys. Very good. Just last question. Just last question, guys. Just last question. A bridge is here, bridge ID is 2000, one more bridge is here, bridge ID is 6000, one more bridge is here, bridge ID is 1400, one more bridge is here, bridge ID is 7000, one more bridge is here, bridge ID is 8000. And suppose this is connected like that, this is connected like that, suppose this is connected like that. So this is creating cycling problem, this is connecting cycling problem. These are the bridge structures, right? So tell me, what is the spanning tree corresponding to this? What would be the spanning tree? What would be the spanning tree corresponding to this? Corresponding to this cyclic problem, this bridging problem, what would be the spanning tree? You need to apply spanning tree algorithm and answer me, guys. This is it. This is the root id 8000, 7000, 1400, and root. You need to answer root port. So root port. This is the root port, guys. This is the root bridge. This is my root bridge. Ashik, you are asking A, B, C about previous problem, kya? That what if we delete A and C and join DC? No, you can't add this because for each bridge, in rule I have told you, in rule in rule of spanning tree algorithm I have told you, for each bridge we need to assign root port, and for bridge C this one would be root port. Why? Because it is the lower id. This is not lower id. If you will compare the id 2000 with 4000, which is lower one? This is the lower one na, a1. That is why it will be root port. So we can't connect C to D, we only need to connect A to C. Is it clear, Ashik? Now solve this question. Okay, let it name it A, B, C, D, E again. Solve it, guys. Solve it. Are you guys solving? No, we don't have any concept of idle node here. Ashik, we don't have any concept of idle node in spanning tree algorithm. We just need to consider on the root port, designated port, and lengths, and whatever bridge entry we have. Other than that, we don't have any existence of any concept here, right? Are you solving this, guys? Have you solved this question? If you have done, answer me that done so that I can solve. I can go for its solution. If you have done it, please answer me that done so that I can proceed for its solution. Answer me, guys. Done. Very good. Okay, so I am making root port now. It is root bridge itself. It is root bridge itself, guys. It is itself a root bridge. So for root C, there are two ports on the left hand side and on right hand side. So I will assign root port to the port which is connected to the laser bridge ID. What is laser bridge ID? 2000 is a laser bridge ID comparative to 6000. So it will be my root port. Similarly for bridge D, left hand side port will be considered as a root port because 2000 is lesser than 6000. The root id of the bridge id of bridge A is lesser. Similarly for bridge E, root port will be of the left hand side because it is connected to the laser bridge id, right? So I will remove this is the root port, and root port for bridge B. Root port for bridge B is this one will be the root. This one will work as a root port because 1400 is much lesser than 2000. That is why this is the root port. Okay, so it is a part of single lane. It is a part of single lane, so we can directly say that I can remove it, I can remove this, and I can remove this. So how my spanning tree would look like? Here it is a bridge A, bridge B, bridge C, bridge D, and bridge E. So it would be look like this, guys. It would be look like this, isn't it? Isn't it, guys? It is my spanning tree. It is my spanning tree. You can assign letter things on it. Is it clear to everyone? Yes, Manjit. If we choose with smallest ID, it should be C. So B is connected to C. That is why we have chosen that, na. But D is not connected to C. D is only connected to A and B. And E is also only connected to A and B. And A is connected to C, but A is root bridge. So no need to assign root port here. And B is connected to A and C. So we have assigned this port as a root. Is it clear? Root port is given as a root A. That is why. Clear, Manjit? What I have told to you, what is the solution? Is it clear that why it is the spanning tree? Actually, root B is there. So if I talk about root bridge, if I talk about root bridge, no need to assign root port to it. No need to assign root port to it, because root bridge will always be a part of bridge. Root bridge will always be part of bridge. You can assign this port and this port as a designated port, but no need, as we are discussing in terms of single lane, as we are discussing in the term of single lane. That is why no need to assign designated port. But here itself again you can assign a designated port, that this port and this port will be designated port for this one and this one, and this will be root port, and this three ports will get blocked. Manjit is saying, sir, if root bridge is not giving, actually root bridge is the essential part of bridging algorithm. Root bridge is a must. Every bridge is a built-in ID. The one with the smallest ID will be taken as the root bridge. Focus on step one, Manjit. The one with smallest ID will be taken as a root bridge. But in question here, in this question, this bridge is given as a root bridge. But if this bridge is not given as a root bridge, then you will consider bridge C as a root bridge. Clear, Manjit? If it is clear, if it is given A is a root bridge, we need to take A as a root bridge. But if we will give that nothing is a root bridge, then you will consider at that time C as a root bridge. Is it clear now? Basically, Manjit, your doubt is right. Basically, we will not consider this as a root bridge. We will consider this bridge as a root bridge. But by default, even in question, such kind of operations are there, that in which higher ID is assigned a root bridge, then you will work according to like that. But yes, according to our rule, we must have to assign the root bridge to the bridge who have a lowest ID. Who have a lowest ID, we have to assign root bridge to that. That is why I am assigning root bridge C as a root bridge. But in question, actually root bridge was assigned to A. That is why I have named it like that. But according to our rule, we need to assign the root bridge to the bridge which have the lowest ID, lower ID. Audible na? Manjit, is it clear? Am I audible na?